All right, let's dive into this research paper on using AI to detect student learning behavior.
Sounds good.
In smart classrooms.
Yeah.
We're talking cutting-edge computer vision.
Okay.
Folks, get ready to explore how AI could reshape education as we know it.
It's really fascinating stuff, yeah.
Definitely.
What's exciting to me is how this research tackles
Yeah.
the limitations of traditional classroom observation.
Right.
You know, teachers have an incredible amount on their plates, and even the most observant ones can miss subtle cues that indicate a student's grasp of a concept.
Absolutely. Think back to your own classroom experiences.
Yeah.
There's always been that challenge of gauging individual understanding in real time.
Yeah, it's really hard.
So now imagine having an AI assistant that could analyze student behavior in a way that's simply impossible for humans to do consistently.
Yeah.
And this research is exploring just that.
Exactly.
The system called SCB-DETR.
And it's tackling this challenge head on by addressing some really difficult hurdles in computer vision, especially within the dynamic environment of a classroom.
You're talking about occlusion, blurring,
Yes.
and scale disparity, right?
Precisely.
These are things that can really trip up AI trying to understand what's happening in a classroom.
Yeah, occlusion happens when students block each other from the camera's view, making it hard to track individual actions. Blurring occurs with fast movements, which can confuse the AI's analysis, and then scale disparity. That's the issue of students closer to the camera appearing larger than those further away.
Yes.
So it makes consistent analysis tricky.
So how does SCB-DETR address these challenges?
Well,
the paper mentions some pretty impressive technical innovations.
the key lies in two main components, the LKNeXt backbone and the HFFA or hybrid feature fusion architecture.
Okay.
Let's start with LKNeXt. Imagine giving the AI a wider field of vision, allowing it to understand not just what a student is doing, but why.
So instead of simply registering a raised hand, the AI could interpret the nuance behind that action.
Yes.
Is the student confidently answering a question?
Exactly.
Or hesitantly asking for clarification?
Yeah.
That's incredible.
LKNeXt uses larger convolutional kernels than traditional CNNs, giving it this enhanced ability to understand spatial relationships and context within the classroom environment.
Fascinating. Now, what about HFFA?
Yeah.
How does that contribute to the AI's understanding?
Think of HFFA as a master conductor, orchestrating information from different scales and attention points to create a unified picture of the classroom dynamics. It uses a combination of feature pyramids and encoders with attention mechanisms.
Okay, let's break that down for our listeners.
Sure.
What exactly are attention mechanisms in this context?
Imagine shining a spotlight on the most important actions within a busy scene. Attention mechanisms allow the AI to focus on specific student behaviors that are most relevant to understanding learning, filtering out the visual noise of a bustling classroom.
So it's helping the AI prioritize what to pay attention to.
Yes.
Just like a skilled teacher would.
Absolutely.
Right.
And this becomes crucial when dealing with the challenges of occlusion and blurring. By combining information from multiple viewpoints and scales. The AI can fill in the gaps and develop a more complete picture of student behavior, even when things get a bit chaotic.
All right, so we've got this incredibly sophisticated system designed to read a classroom. But how do we teach it to actually recognize specific student behaviors? This is where the training data comes in, right?
That's where the SCBehavior dataset comes in.
Okay.
The researchers created a dataset of real classroom images specifically designed to train SCB-DETR on 7 common behaviors. Writing, reading, looking up, turning their head, raising their hand, standing, and discussing.
A pretty solid representation of what you typically see in a classroom. And how did SCB-DETR perform after being trained on this data set?
They tested it against a whole lineup of other state-of-the-art AI models, and the results were remarkable.
Do tell. What kind of accuracy are we talking about here?
In their tests, SCB-DETR achieved a mean average precision, or MA, of 0.626.
Okay. For those of us who don't speak AI metrics fluently, what does that number actually tell us? Paint a picture for us.
It means SCB-DETR is remarkably good at correctly identifying and classifying these 7 student behaviors in real classroom images.
So not just a small improvement, but a significant leap forward in accurately understanding what students are doing.
Exactly.
And perhaps more importantly, what that tells us about their learning process.
Precisely.
Wow.
It significantly outperformed the other models, demonstrating its potential for transforming how we approach student engagement and personalized learning.
So,
of course, with any powerful technology, especially one that analyzes human behavior, we have to consider the implications carefully.
That's a great segue into a discussion about the real-world applications of this technology and the ethical considerations that come with it.
Absolutely.
But before we dive into that, let's take a moment to fully unpack the technical marvels behind SCB-DETR.
All right. One of the things that truly impressed me about this research is the depth they went into regarding the technical architecture of SCB-DETR. They delve into the crucial role of backbone networks in computer vision and how they are the foundation for everything else the AI does.
It's like the backbone sets the stage for the AI to understand what it's seeing.
Exactly.
But they argue that a general purpose backbone isn't ideal for a specialized environment like a classroom. Why is that?
Well, think about it. Classrooms have a very distinct visual language. You've got whiteboards, desks arranged in specific ways, and students often wearing uniforms. A backbone designed for something like facial recognition or self-driving cars wouldn't be optimized to pick up these unique patterns.
So LKNeXt's power comes from being specifically designed for the classroom environment.
Exactly. By using larger convolutional kernels, LKNeXt is able to capture more of those spatial relationships between students and the objects around them. It's like giving the AI a deeper understanding of the context behind a student's actions.
That makes me think about the ethical considerations we touched on earlier.
Yes.
The more detail the AI picks up, the more sensitive we need to be about how that information is used. It's a powerful tool that needs careful handling.
Transparency is crucial here.
Transparency from schools, developers, everyone involved. Students and parents need to be part of the conversation,
I agree.
understanding how this technology works and what safeguards are in place.
Absolutely.
Now, beyond the backbone, the researchers also highlight the unique design of the HFFA architecture. Especially its ability to handle the challenge of scale disparity. Can you elaborate on that?
Remember how we talked about students at different distances from the camera appearing different sizes? HFFA tackles this by creating a multi-layered understanding of the classroom scene. Imagine a pyramid where each level represents a different scale of detail.
So I'm picturing the bottom level showing the whole classroom. And as you move up the pyramid, the focus narrows in on individual students and their actions.
Precisely. And the attention mechanisms we talked about earlier play a key role here. They guide the AI to prioritize which features at each scale are most important for understanding specific behaviors.
So it's not just about seeing everything. It's about seeing the right things. HFFA ensures that the AI doesn't get bogged down in irrelevant details.
Exactly.
And this sophisticated approach is also vital for tackling occlusion and blurring. By combining information from multiple scales and viewpoints, the AI can fill in the gaps and get a more complete picture. Even when students are blocking each other or moving quickly.
It really is impressive.
It's remarkable how much thought goes into designing these systems.
It is.
They're essentially building a digital brain that can see and understand a classroom in a way that's similar to, but even more precise than humans.
It's a testament to the ingenuity of the researchers and the advancements in computer vision.
For sure.
And while the technical details can get complex, I think it's crucial for us to grasp the basics.
Absolutely. Understanding how these systems work empowers us to have informed discussions about their potential benefits and risks, shaping how AI is used in our schools and our lives. What stood out to you most in this research?
What resonated with me was their emphasis on the need for specialized AI models tailored to specific environments. We hear a lot about breakthroughs in AI, but they often focus on general tasks like image recognition or natural language processing. This research highlights the need to go deeper to develop AI that's specifically designed for the unique complexities of different fields like education, healthcare, or manufacturing.
Well, because a one-size-fits-all approach to AI might not be the most effective or ethical solution, right?
Exactly. It's about moving beyond the hype and thinking critically about how AI can be used to solve specific problems responsibly and powerfully. And this research is an important step in that direction. It's a glimpse into a future where AI could truly transform education, empowering both teachers and students.
But it all comes back to responsible development and implementation.
Of course.
We need to ensure that AI in education is always grounded in ethical considerations, enhancing human potential rather than diminishing it.
I couldn't agree more.
This research gives us a lot to consider.
It does.
Both the exciting possibilities and the ethical challenges.
Absolutely.
As AI continues to evolve, this conversation is only going to get more crucial.
For sure.
Now that we've thoroughly examined the technical intricacies of SCB-DETR, let's shift our focus to the practical applications of this technology. How might this system actually be integrated into different learning environments? And what unique advantages and challenges might arise?
That's a great question.
So it's time to really explore the real-world potential of SCB-DETR. Where do you see this technology having the most impact in various educational settings?
One area where it could be incredibly valuable is large classrooms or lecture halls, where it's challenging for a single teacher to gauge every student's engagement effectively.
That's tough.
The AI could provide that extra set of eyes, alerting the instructor to those who might be struggling or disengaged.
It's like having a co-pilot in the classroom.
Yeah.
Helping the teacher navigate the complexities of student engagement in real time.
Exactly.
This could be particularly helpful for new teachers still developing their classroom management skills.
Precisely. The AI can act as a support system, offering data-driven insights to inform their teaching strategies.
Okay, so that makes sense in those larger settings.
Yeah.
However, in smaller, more intimate learning environments,
the
value proposition might shift a little bit.
Yeah, that's true.
In those settings, teachers likely already have a good grasp of individual student needs.
Right.
Could the presence of AI be detrimental in a way?
It's possible.
Perhaps creating a sense of unease or constant surveillance.
It's a valid concern.
Yeah.
Trust and rapport are essential for effective learning.
Right.
And the feeling of being constantly monitored could undermine that.
Right.
In such cases,
the
implementation of AI would require careful consideration and a focus on transparency.
It's not just about the technical capabilities. It's about the psychological and social impact on the learning environment.
Absolutely.
Striking the right balance between technology and human interaction is key.
I agree.
But let's shift our focus a little bit to online learning environments.
Okay.
I think this is where SCB-DETR could truly shine.
Yeah, I think so too.
Imagine a virtual classroom where the AI can track not only attendance, but also a student's level of engagement with the material.
That would be huge.
Analyzing how long they spend on each page, their participation in discussions, even their facial expressions, to gauge understanding.
It's about bringing that level of personalized insight.
Yeah.
That's often missing in online settings.
Totally. And instructors could receive valuable data to tailor their approach.
Exactly.
Making the experience more engaging and effective for each student.
Absolutely.
And critically, identifying those who are falling behind or need extra support.
Yes, that's key.
This goes beyond mere surveillance. It's about leveraging data to create a more supportive and responsive learning environment, even in the virtual world.
Precisely.
Wow.
Ultimately, it's about using AI to make education more accessible.
Right.
Equitable and human-centered.
This deep dive has been fascinating.
It has.
We've really unveiled the incredible potential of AI in education.
For sure.
But a potential matched by equally important ethical considerations.
A sentiment I wholeheartedly echo.
Yes, absolutely. As AI continues to advance, open dialogue and ethical considerations will be paramount.
Couldn't agree more.
This has been an insightful exploration, to say the least.
It has been, yeah.
The possibilities are exciting, but responsible development and implementation are critical.
I agree.
As AI and education evolves, we'll certainly be revisiting these topics.
Absolutely.
Thank you for joining us on this deep dive.
It's been a pleasure.
And to our listeners, thank you for tuning in.
Yeah. Thanks, everyone.
Until next time, keep exploring, keep learning, and keep diving deep.